Okay, so right now in front of me, instead of a series circuit, I have set up a parallel circuit with two bulbs. And then what I mean by parallel means that there's more than one path for the positive charge of the conventional current to flow. So here's my positive terminal. It's connected to the spring, positive, negative end of the battery, right? I have it connected to the positive, so I start off with 4.5 volts here. I have two alligator clips on this first bulb because either the current can go into this bulb or it can split and go into this bulb. So there's two options for the current to flow that's providing this electricity. Technically, like I have always said, it's actually the electrons moving, but for circuit convention and notation, we're taking it as positive charge that flows. And here, so I can either go into this bulb or I can go into this bulb. And then after the current is given an option, the voltage is dropped down to 0 in both of these bulbs so that both wires can return to the negative terminal of the first battery, which is why I have both alligator clips hooked up to the negative end over here. So even though current splits at this point, even though current has two options, the amount of push is the same because it didn't encounter a resistance yet. So that's the difference between series and parallel circuits. The total current is the thing that splits in a parallel circuit. It doesn't equal the same. The current in a series circuit is the same everywhere. Current in a parallel circuit is not the same everywhere because it splits. Which means that the total current here, before it even gets to the bulb, the total current of the circuit must equal the current going through here plus the current going through here. So because more than one path for current to flow. Okay, and this is called Kirchhoff's current law. Kirchhoff's current law. And the voltage, like I just said, when the current splits between going to this bulb or this bulb, the voltage must be the same here and here because it didn't encounter resistance yet in the first place. It split before it encountered this bulb or this bulb. So the total voltage is going to be the same. It's kind of the opposite of a series circuit. So V1 equals V2, which equals V3, which equals ... However many points in the circuit we have. This is the first light bulb, for example, V1, and the second example, V2. So series and parallel are inverses of each other in that sense. And then the total resistance or equivalent resistance, it's just a fancy word for total resistance of the circuit, actually lowers for a parallel circuit. And I'll explain what that means in a second. If we look at the equation for calculating equivalent resistance, REQ, aka total resistance, the equation is 1 over R1 plus 1 over R2 plus 1 over ... If you have more than two resistors, that's where you'd fill in the ... So what this means is that as you increase R1, this thing is going to be small, which means that this whole thing is going to be even smaller than this small. Which means that as you add resistance in parallel, the total equivalent resistance will go down. And what does Ohm's law say? I equals V over R. As equivalent resistance goes down, what's going to happen to the current? It's going to go up, right? Because I and R share an inverse relationship. And this is important for, let's say if you're an electrician or you're trying to wire something in your house, or you're trying to get a bulb to be bright or not bright. Do you pick to put your light bulbs in a series or a parallel circuit, well, let's say if you wanted them to be as bright as can be, but have a lot of bulbs in them, right? I would pick a parallel circuit. It allows more current to flow, allows them to be brighter, even if you keep adding more light bulbs in parallel with each other, because it will overall decrease the equivalent resistance, which is different than in a series circuit, right? You would find the total resistance by just adding up the resistance of each bulb or each resistor, for instance. But in parallel, we obviously see that that's not the case. So the main difference between a series and parallel is that series circuit, if you increase resistance, well, it's not how I spell resistance, you decrease the current, and if you increase resistance here, you will increase current. And these conceptual relationships that differentiate between series and parallel circuits is exactly why that happens.